Assalamualaikum. I am Chris, here to present my progress report for semester 7, June of 2024. Recap on the research. My research title is Flight Simulation Assessment of Novel Flight Fixed Wing Multi-Rotor Hybrid Agriculture Drone. The table of content for this presentation are the following. For introduction, the fixed wing multi-rotor hybrid drone is to be designed for the purpose of agriculture, in which case we will be using a fixed wing drone rather than a multi-rotor drone that is prevalent in the industry now. The novel design comes from Professor Dr. Rizal Effendi of FTTC in UiTM. This is a novel design in which it uses no control surfaces for its movability in the air. The purpose of this project is to make a UAV that is easy to fly, reduce the cost of purchasing from big companies, as well as improve on old methods of taking care of crops. The objectives are as follows. Investigate the flying quality and dynamic stability of the fixed-wing multi-rotor hybrid to synthesize a suitable control method augmentation for this design and to evaluate the flying quality of the control method. This is the design within the context of the X-Plane 11, which is a flight simulator that is being used for this research. The design is being implemented into AutoCAD as well as CATIA to be able for ease of 3D printing as well as editing in the internal functionalities of the aircraft itself. The model from which the design came from in CATIA is introduced into SolidWorks and then into the 3D printing software to create the prototype. The 3D printing process is showcasing the 3D printing process as such. And the construction of the UAV in real life. The controlling method of the aircraft prototype is using a Pixelhawk flight controller as well as a FlySki radio controller with 4 rotors. As mentioned, does not use any control surfaces to control it during flight. The schematics for the internal workings are as follows, following the Pixelhawk standardized wiring system and schematic. The testing of the rotors was done in the lab, whereby started with 1 rotor and then move on into 4 rotors and then implemented into the aircraft itself in assembly. As seen in the video, the first rotor functions well with the response of the controller.
Okay Prof, sekarang
Currently, the design prototype is not yet flown. This is due to the progression of the research, in which I plan to conduct the viva voce before finishing the prototype flying. A progress from last semester, the acceptance letter came for the publication of the research. The research can be found in the web of conferences under the author Mukris Mazlan, and my current progression in thesis writing. Chapter 1 I've sent to my supervisor for approval. My chapter 2 I've only written on the background of the aircraft designing. Chapter 3 the methodology of the aircraft design and research have only been implemented in the practical sense. Chapter 4, all results are already available. I have just left to write it up. And chapter 5, only 10% because the only objectives is achieved, but how it implements into the conclusion of this research have yet to be decided. My planning for the next semester is to send a letter of intent for viva voce and my thesis submission, so to hopefully graduate as a Masters of Research, Masters of in Science in Mechanical Engineering. Thank you.